Hello all, welcome to our channel. Where to know? We'll continue our discussion on the STM32 Nucleo board. So, when you're working on any microcontroller boards, whether it be Nucleo board that we are talking now, or if it is a Arduino board or MSP432 board, whatever board you are working on, there are two important documents which you need to have handy while working on these boards. So the first one you see here is the schematic part of this Nucleo board, and then second one is the data sheet. So these two are the documents which help us to understand the eval board that is being designed. Okay, now while working on this eval board, we need to understand how the power is distributed to this. While the eval board is mostly meant for programming and getting your code up and running on the board, it is important that you need to know how the power is distributed, what are the specifications of this microcontroller, and if you want to interface something to the board, you need to know what are the compatible things and what can be connected, what cannot be connected. If something need to be connected beyond the specifications, what need to be done. So these are all the design part that we need to understand. So the first thing here, let us look at this particular point. Okay, so the operating voltage of this particular MCU is 1.7 to 3.6. That means it's a wide range power supply. It covers both 1.8 as well as 3.3 volts, while it doesn't have compatibility for the 5 volts. Okay, so mostly when we are working on MCUs, we look forward mostly whether it is working on 3.3 volts, and then the second preference will be 1.8 volt. And sometimes we also look at if some of these particular IO pins of this MCU, whether they are tolerant to 5 volts or not. Like if you scroll down to a little bit, you can see here up to 77 5 volt tolerance IOs. That means even though you give 5 volts, these particular IOs are tolerant. So for now, let us keep this aside and let us focus on the power supply. So now as this says 1.7 to 3.6, what is there on the Nucleo board which we need to understand whether it is 1.8 volt or whether it is 3.3. So for this, you can see here on the Nucleo board, the power is distributed like this. Okay, you see there is a regulator here U4 which is generating 3.3 volt, and this 3.3 volt is connected through a jumper JP6 and VDD is generated. So VDD is the output of this regulator. Okay, so to this regulator the input is 5 volts. So this 5 volts is either coming from this particular regulator or from this particular 5 volts through a MOSFET. Okay, where are we generating this? Okay, if you see U5V, let us start with this U5V. Okay, U5V is actually coming from the USB connector where you plug in the ST-Link USB cable to power this particular Nucleo board. So that means the power to your board starts from this particular USB. As you all know, only when you plug in you get the power, right? So that means there is 5 volts that is coming from your laptop or the computer which you connected, and that 5 volts through this MOSFET is coming here, and in the JP5 1 and 2 must be shorted. Okay, you can check your board, 1 and 2 will be shorted, third will be open. So that means this jumper will be placed and you get the 5 volts, and this further generates the 3.3 volts. So what about VIN? Where does VIN come from? Okay, VIN, if you scroll down to the connectors, it's from the Morpho connector or the Arduino connector. You can see Arduino connector 8th pin or the Morpho connector 24th pin has an option to generate or to provide input to this particular Nucleo board, from which VIN is connected, and this VIN is routed to this regulator which further generates the 5 volts. Okay, so and then this 5 volts whether you can give from the USB or you can give from the Morpho connector. On our board we are giving from USB, so as we mentioned JP5 is shorted, and this is where you get the VDD. Okay, now if you go to the microcontroller, the STM32 F411 microcontroller, you can see the VDD pins. Okay, VDD pins are the pins to which we connect the power supply. Okay, you see VDD is connected through a bead and then a jumper. Sorry, VDD is connected directly or through a jumper here. Okay, or VDD is also connected to the VDDA. VDDA is the analog supply to this particular microcontroller. So if you want to use ADC on this microcontroller, you need to have power connected to the VDDA. Okay, so VDD and VDDA are connected through the jumpers or directly to VDD, which is nothing but 3.3 volts. Now we know in the Nucleo board there is also another microcontroller, right? Which is the ST-Link microcontroller. So if you scroll down, this is the ST-Link microcontroller in the schematic. Okay, so this also will have power, right? Every chip requires power. So now this particular microcontroller is powered through another regulator here, as we highlight, and the U5V or E5V are connected through the diodes to just avoid any back operation, and it generates the 3V3 ST link separately. So the regulator generating power to the microcontroller main controller is different from the regulator powering the ST link. Okay, so this 3v3 underscore ST link, as we see here, is connected to the VDDA and also the VDD pins. Okay, so this is how the power is distributed. The basic power configuration is done in a Nucleo board. Now you know that the main controller is getting powered separately, the ST-Link is getting powered separately. To avoid any power issues or power sequencing issues, what they have done is they have something called power enable, which is actually controlling the gate of this particular MOSFET, such that only when power enable signal comes, the U5V will be passed to this particular LDO. So that means in our circuit, we have to understand that first ST-Link power should be up, okay, and then comes the main controller, which is the correct sequence of powering the board. So this is how the board powers up. And in case if you want a 1.8 volt requirement, might be we might have to use a different regulator, or it's a little complex thing. If we have to see how good this board is designed, whether VDD is distributed at what places, we have to see and then check if this supports 1.8 volt or not. For now, the Nucleo board clearly supports 3v3, which actually called a VDD signal, and is connected to the microcontroller. Hope we gave a glimpse of how power is distributed in the STM32 Nucleo board. Please post if you have any questions. So we specifically suggest, when you are using the Nucleo board, use a multimeter, probe across different points of this STM32 and get to know the main power points and measure with your multimeter, so that you get a good hands-on and also clarity on what all power distribution is happening on this particular board. Thank you.